Distinguished guests, dear guests, ladies and gentlemen, dear friends, good afternoon. Welcome to the breakout session of HEC 2020, Cloud Compact 2.0, Innovation in our New Solutions. Good afternoon. Welcome to this breakout session. I'm the moderator of this session. I'm Hua Zhen. I'm very glad to meet you all here and to join hands with Huawei and create new value for the industry. First of all, please allow me, on behalf of the organizer of this conference, to extend our warmest welcome and heartfelt gratitude to all our friends present at the conference. Welcome. We are now in the age of all wireless world, and it is changing our way of work and life. It is also impacting the digitalization process of all industry, from design, research to sales and after-sales service. It has covered all the production lifespan. And actually, the digitalization transformation has brought a lot of challenges to our management of campus. Here today, we are talking about, in the age of all wireless world, how can we enable better digitalization transformation with our new solutions. Now today we have with us three guests who are going to bring with us their insight. They are Mr. Zhu Cao and also Mr. Ma Yan and also Mr. Zhao Jinsong. Now let's have our heavyweight speakers on the stage. Now please join us in welcoming our first speaker, Mr. Zhu Cao, who is going to talk about how GBPS is going to enable a new future. Now let's welcome our first speaker. Today, I'm very happy to share with you our Cloud Campus 2.0. In the first session, we were talking about the terminals that we produce, which are quite tangible. But behind the 10 terminals, we have connections. If without connections, we cannot gain access to internet. We cannot gain access to cloud. Therefore, today, let's say how our Cloud Campus product can help enterprises with their digitalization transformation. We are also going to share with you our practices. Now, here comes my topic of presentation. That is Cloud Campus 2.0, which will help the park network enter into an age of wireless intelligence. First of all, let's see what IDC has to share. In the analysis of IDC in the year 2007, we have been entering into the first stage for digital transformation. What does it mean to all of us? I guess many of our friends have the following feelings. It is mostly about those peripheral businesses of an enterprise. Say, for example, paperless business, for example, mobile business, etc. And in that stage, we call it digitalization 1.0. At that time, you can see that people are beginning to use IT solutions on a massive scale. Now, they become more familiar with application. Now, cloud computing and big data are buzzwords at that time. Beginning from the year 2015, IDC believed that we are entering into a stage of digitalization 2.0, featuring changes in technological innovation. That is to say, incremental innovation, featuring IoT technologies and the blockchain technology, among many others. And what are the prominent features of this age? That is to say, innovations are popping out on a more massive scale. And you can say at this stage, for the core business of many enterprises, begin to become digitalized. But still, there are part of the business that remain undigitalized. It is projected that by the year of 2023, we are going to enter into the stage of digitalization 3.0. In other words, enterprises are going to realize 100% digitalization. And then we are going to see, for example, quantum computing, etc. Now we are in the second stage. Against such a backdrop, we are proposing our Cloud Campus 2.0, which is looking forward to the future to meet the needs of enterprises in the future. And when enterprises are carrying out the digitalization revolution, internet is lying at the bottom, serving as the foundation. You can take a look at this slide. Now, this is a triangle with 3 points. At the top point, we have the physical part, that is access to all the objects on the edge, and that is used for the purpose of serving the needs of people. You need connection with people. On the right lower hand level, then you can see the cloud end, which is providing us computing capabilities represented by application, etc. Between the edge and the objects, we need interaction by perception. And also we need smooth communication between and among people as well. On the cloud level, between different applications, we need to have computing with zero latency. Therefore, man to object have interaction requirement, and also man to man needs smooth communication as well. Now, you can see some wearable devices, some VR and AR products are now becoming part of our life. And also, you can see some other connection requirement, say, for example, for AI detection. Once data is captured, it has to be sent to the cloud for a real-time calculation or computing. And there is also a need for connection between application and human beings. Now, most commonly we see what we call co-location work or collaborative work, which needs this kind of connection. Therefore, digitalization of enterprises has brought about a lot of different challenges to us. Now, I want to share with you our insights from 4 different cases. The first example is about what we call a wireless or intelligence business day. Therefore, when you go into an office, you have already entered a digital environment. Once you go into the door, there should be face recognition. And after you have entered into the office, there are light control and control of temperature, among many others. There are electronic printing services. There are online reservation of meeting room. And we have a high resolution or high definition video conference services delivered to us. These are all part of intelligence office space. You can also take a look at the 3 indicators on the right-hand side of our slide. At the present, speaking of a collaborative office, video conference has accounted for 80% of the collaborative business. And also, nowadays, more and more enterprises are using fully wireless office. You can barely see those optical fibers in the office. And thirdly, it is about the growth rate of the internet of terminals connected to IoT. You can see within 3 years' time, this penetration rate has reached 83%. Behind all these figures, there is a need for the increase in bandwidth. The connection points are increasing day by day, and the connection requirement goes up day by day. To enable fully wireless intelligence office, we need to have fast and convenient access. In the same time, it needs to be safe and reliable. We don't want attacks from outside and disruption from outside. However, speed and safety are a pair of paradoxes. And then here on the left-hand side of our slide, you can see this is a requirement of some of those applications and softwares used in the 1.0 stage. At that time, the bandwidth is quite limited, about just 2 megabytes or 4 megabytes, etc. Later on, you can say with the development of AR, VR, and also cloud-based collaboration, there is increase in demand for bandwidth. And the third challenge lies with the operation and maintenance of networks. How can we well operate and maintain these different terminals that are connected to the network. Once problems occur, how do we do troubleshooting? So you can say device increase by 5 times, but the manpower for operation and maintenance has increased very limitedly. So this is a pair of contradiction as well. Therefore, we are proposing Cloud Campus 2.0 to help enable a fully wireless intelligence office environment. Now here we have 3 basic concepts to share with you. We need to have the basic bandwidth that is a foundation for everything else. And we are using Wi-Fi 6 technology. By using this technology, our bandwidth is several times higher than conventional ones. And secondly, we can do wireless connection or access. For one or each and every user, the bandwidth can be just 1 to 1.6 gigabyte. So it is very wide. Therefore, you can download a film or video within seconds. And then sometimes, even if Wi-Fi is quite good in coverage, the user experience is less than satisfactory. Therefore, we need to do smart connection and access. Once the terminal is connected, there should be insensitive access. And when the roaming service is provided, there shouldn't be any latency or delay in the communication service. And thirdly, for application of my business, it should not be disrupted. Say, if I wanted to talk to my family member quite far away, I want the quality of the video to be quite good. And we need to also do proactive maintenance and operation of the network. In the past, we do it in a passive way. We wait until problems happen. But now, through use of intelligence, we want to do it in a more proactive way and a more active manner. And through these concepts, we wanted to enable better solutions to our clients or to our users to give them better user experience. Once our user is connected to the internet, then we will know instantly when he has a poor experience, whether he has suffered a packet loss or not. So this is about how we help with building wireless intelligent business office environment. Secondly, is about the application of our solution in production. Now, before the concept of a flexible production, in the past, people were talking about so-called rigid production line. Things were done in in big batches with a fixed production line, producing single products.
Now we want things to be customized. We want our cars, we want our bags to be different from others. So we now need a flexible production. It means the production line can be changed according to our needs. For example, we want a different color of a car, so we can change the color setting of this production line. And most of such settings is small scale. First, equipment should be wireless. Sensors of this production line should be wireless. I can give you an example. AOI, the Automated Optical Inspection. In the past, we needed manual inspection to check the circuit boards of AOI. But now, AOI can be inspected with HD cameras. For example, we have a production line of home appliance. It uses 5 industry cameras from top, front, back, left, and right. And photos taken should be uploaded to the cloud. We can see, as calculated, for one AOI, the bandwidth is 765 megabits a second. So 5 AOI may require gigabit of bandwidth. This is a big challenge. Before Wi-Fi 5, there was no such a capacity to satisfy gigabit transmission. And the second challenge comes from reliability. Because there's a continuous flow of production line, there shouldn't be any stop on the production line. So we say the reliability should be at least 5 nines. and reliability may be compromised when everything is wireless. So how to face up to these challenges? First, we use Wi-Fi 6 AP, providing 16 spatial streams to provide double the capacity at 10.75 gigabit per second. And second, in order to reduce interference for uplink backhaul, we have dual link backhaul of both 2.4 and 5 gigahertz. These are some real practices in production lines. And now the change of the production line can be shortened from hours to minutes. And next, I will tell you a story about teaching and study. Indeed, we have many such scenarios. VR and AR are used in enterprises and also in classrooms. In the past, many contents were stored locally. And it is very expensive to make VR content. A 5-minute VR video may cost tens of thousands of yuan, and also it may need high-performance computing locally. So parts of the content should be put locally and the other parts on the cloud. But if we put everything on cloud, such local storage may not be needed anymore. Then let's take a look at some changes or challenges imposed by VR. The first one is terminal processing. Terminal processing requires really high definition. And the second is latency. Maybe you have such an experience when you are using VR. Things should be in real time, otherwise you may feel fainted. And the latency, as written here, should be minimized to less than 20 milliseconds, especially for wireless, because wired transmission can reach such a level, but not the same for wireless. It is difficult to make wireless latency to 10 milliseconds. Now in the industry, most of the latencies for wireless is around 20 milliseconds. But for Huawei, we can minimize the latency to 10 milliseconds. First, we need to identify the application. First, we use neural network algorithm to know this is a VR application. And then we have accelerated scheduling of resources to guarantee VR experience. And also, I'd like to talk about intelligent O&M. We need to guarantee network experience. So intelligent O&M is needed. Here, the experience is visible by using machine learning. Everything is demonstrated. And if there is a fault or an error, we are able to locate the fault in 5 minutes. The last story is about finance. Every one of you has visited finance branches and banks, but maybe you haven't been there for some time. When was the last time you visited a bank branch? Now, many operations are done on your phone. So banks need to change their services as well. In the past, they were setting flagship financial branches, but now they build community financial branches. But they are more of community types because they need to serve massive communities, and such branches are built in smaller sizes. First, such branches need to cope with temporary financial service requirements, and such rollout should be completed within 1 day. And second, they need to provide remote financial service. Some remote service operator can serve you just as they are in front of you to provide you in-person experience. And third, they now have a large number of scattered financial branches. How to manage so many scattered branches? This is another challenge. So we hope to help banks to build mobile, intelligent financial branches. Here we use 5G Super Uplink. It means in one hop, your service is moved to cloud. It can provide 230 megabit per second uplink bandwidth, about 20% higher than before. And this uplink backhaul is quite safe and secure. And we are able to provide you multiple transmission and receiving routes. At the same time, we can also use Wi-Fi 6 to cover branches, but also we can use wired coverage. For example, we can build some intelligent exhibition hall APs to serve customers locally. And also, we can use cloud to cover both the head office and all the branches. So this is very convenient. There's no difference between the head office and the branch. Everything is managed centrally. So this is my very last story. Let's put everything together. Huawei provides Cloud Campus 2.0 solution. So how will this solution help enterprises to do digital transformation in the 2.0 age? As I've mentioned, we have three concepts of intelligence. First, we provide high bandwidth from end to end, from wireless access to wide area network, all the way to the core. And we can also provide you guaranteed experience. When you access the network, you do not need to wait. You can use the network immediately. And the experience is guaranteed no matter you are using it in a place or you are roaming. And also, our network is autonomous. We can provide you intelligent operation and maintenance. Now, not a lot of vendors can do automatic operation and maintenance, and we are very willing to work with partners and customers to do digitization. That's all for my part. Thank you.
Okay,
thank you. Thank you, Mr. Zhu Chao, for your sharing. And also, we are expecting Cloud Campus 2.0 solution to come to the market and serve more customers. Today, we have also prepared for you some gifts. So you can scan the QR code here on the screen and fill in the questionnaire, and then we will provide you the gifts. There are 10 gifts in total. You can fill in this questionnaire after scanning QR code. Then maybe you are the lucky guy to win Huawei GT2 sports watch. And now there are also many audience online, so you can also fill in the questionnaire in the notice billboard. You just need to go to the WeChat public account and then fill in the questionnaire, and you have the chance to win the gift of Huawei GT2 sports watch. And please save the snapshot after filling the questionnaire and use the snapshot to win your gift. And now let's come to the second topic. We all know area network is very important for campus network. And the area network has not changed a lot, except for seeing a higher bandwidth. But now, do we need to take a revolutionary change in the area network in the new age? So now let's welcome Mr. Ma Ye to share with us the second topic on how to build a high-quality campus area network. Hello, everyone. I'm Ma Ye. I'm responsible for the development of Huawei Cloud Engine S series switches. and how we build high-quality campus peering network. As you can see, now we are in the second generation of peering network of digitization. In the first generation, we cared about data accessing and storage, but in the Generation 2.0, we care more about AI, big data, and many smart technologies. We care about the development, the evolution of these technologies. And there are mainly three changes. The first one is wireless. When you are working in a campus, you use wireless network. And the second keyword is cloud. Most enterprises put their business on cloud. And the third one is IoT. We see many devices are connected in campus. No matter we are working with service provider, vendor, or partners, we are always asked how to better support IoT in the future, how to better manage this network. After seeing these three new challenges, how to face up to them, we see the new challenges for campus network are helping us to build a digital foundation. We see Wi-Fi 6 in recent years is a hot topic, from Wi-Fi 4 to 5 to 6. We see the campus network on accessing layer is gaining more bandwidth, and also there are changes in PoE. Many applications are built on cloud. For example, now we are having teleconferencing with customers. We're having business negotiations with customers on cloud. So experience is very important. We need to guarantee good experience while we are working with customers on cloud. And after building big networks, we need to help enterprise IT staff to build networks quickly and maintain the network. These are some challenges we are seeing now. And then I will talk about how to support enterprise to gain high bandwidth wireless access. This is my first part. As we can see with the development of Wi-Fi technology from Wi-Fi 5 to Wi-Fi 6, no matter our Wi-Fi 6 or Wi-Fi 6 from other vendors, we see now 10GE is supported in uplink interface. And Wi-Fi power is improved from PoE to PoE Plus to PoE++.
This put forward great demand for the bandwidth and the power supply. And for our switch, each year we deliver around 2 to 3 million units. For those mainstream ones, just at the level of a megawatt. And now, the building of the campus at the present, if compared with the future campus, there is still a gap in between. With the development of cloud business, we don't go to cloud for the purpose of going to the cloud. We build a lot of things on the cloud. You know, a lot of applications are going to the cloud, either for office work or for holding meetings. So there is the increase in demand for cloud-based application. And this year, you can say, those companies whose stock prices goes up very quickly are those providing cloud services. And for other, there are a whole lot of other enterprises whose stock price also go up that produce those cloud-related equipment. At the present, the most wanted switch that we deliver is just each year we have to deliver 450,000 units that are having. For the campus, if we are moving from the 1,000 megawatt to 10 gigawatt, we'll have to hugely increase our performance. Now, we need to build an ultra-wide campus network. The switch needs to solve the problem in the following 3 aspects in terms of architect, equipment, and the business model. In terms of the architect, you can see from the left side of our picture, this is the evolution of the conventional architect. You can see it in the buildings. Now, we can see the access from the desktop, and then it has altogether 3 levels. For the present architect, we can provide this campus to shift from kilomega or kilomegahertz to the 10 gigahertz. And then for ultra-high bandwidth, we can also provide a kind of flat architect. We can use this 10 gigabyte switch or to these 40G to 100G switches for the high-speed architect. And actually behind them we have the device and the chips. Ever since the year 2019, we are launching our brand new product, Cloud Engine S series. And then for left side, you can see that is a multi-GE, multi-rate switch. This is the second one. You can see for this multi-GE, now we are using Cloud Engine S 5732 series switch, in which we have a 1.2G EMP chip with high programmability. And then we have a bandwidth of 48 5G access, and then we can enable 48 10 gigabyte full speed access, and then we can say for within one cable. We have been using those optical fibers that are used in the 5G age. Then we can achieve a kind of 10 gigabyte optical transmission. And then you can say across the whole campus, we can flexibly deploy the Wi-Fi network. And in the Nanjing, in one of the universities there, while we are helping them rolling out the Wi-Fi network, you know, for the traditional switch, we are making comparison between the traditional switch and our switch. Then the customer has bought this kind of compound optical fiber for the solution. What is its advantage? You know, for the dorm rooms and also for the classrooms, when they are deploying the Wi-Fi, their initial bandwidth would be 10G. And also the distance for power supply can be very long. Then they can have no longer need a local power supply. Actually, you can say within the dorm, they can just find a place to get our optical compound fiber to enable the power supply. There is no need for them to change the circuit anymore. Therefore, this is a very advanced solution to the university. And together with Wi-Fi 6, now they are building up a brand new dynamic campus network. And in the middle, we have the S127 switch. This is developed based on our self-developed chip. And this is a kind of, we have our 1.4 G switch capability for one single sink. Therefore, you can say it is equal to the C90 switch function performance. And it does not use the conventional the architect. You know, for this present conventional architect, usually for those switch network and also the fan would be put at the back in the backward, which is not very convenient for maintenance and operation. But now in this new architect, for this, our switch can be put into a more flexible space. And then thirdly, it is about the access level. We have a programmable S5732H switch. Therefore, our bandwidth is now shifting from G GB to 10 GB. And in terms of business model, as many people think that the shift from gigabyte to 10 GB, would there be a huge load for the business of the campus network? Then we have RTO Lexens. We have proposed the so-called elastic carriage concept so that the enterprises with less investment can build a better network to the future. So for campus network, it has the following features. There are different terminals that are connected, so from the cameras to our servers, and also the business are different as well. When we are building the campus network, when we use a Cloud Engine S 5732S, you can begin with G or 2.5G. When we want to expand it to 10G, our users can only buy the license of the software to do the upgrading. Therefore, according to our calculation, if you use the Cloud Engine S5732, we can reduce our capex by around 38%. After we have built such a good campus network, next, we need to consider a better experience for our users. Actually, for the campus network, as I mentioned just now, there are different terminals that are connected. Secondly, there are different network requirements for different businesses. We have AGB business requirement and also office requirement. There are different requirements for packet loss as well. And then, as regards the congestion of the network, it is firstly we need to consider the scheduling. So there might be problem happening to scheduling. Secondly, there should be problem with the message forwarding. So no matter for which one of the problems, we need to know in the architect, we need to find the problem with the forwarding chip. And when the message is being forwarded on the switch network, then we need to also EMP might go wrong when there is a packet loss or other problems. So therefore, in that process, how can we solve these problems? We are learning from HQs, from the core routers, and also the switch technologies for solution of the congestion problem. If we wanted to open a menu of any commercial switch, usually they support 2G peers, either for different business or for different users. And for our core switch, for S127001, we have been using router EMP HQ, so as to realize 5G SQs. And there it would be intelligent scheduling that is built on this, so as to make sure that our campus network can have a better or a finer management. And then thirdly, it is about the cell switch. And now we are using switch family technology that we used to use with the core switch, so that there would be a congestion-free cell switch and message forwarding. And then thirdly, speaking of operation and maintenance of the network, there are a large number of terminals. There are a lot of changes to it as well. It is difficult to deploy the network, and it is difficult to manage it. You know, sometimes we are the message senders, sometimes we are the receivers. Therefore, you know, there are a lot of the changes going on across the network. Therefore, in our plan of Cloud Campus 2.0, based on our SDN plan, we wanted to ensure there would be automated deployment and operation and maintenance of our network. Based on this solution, in the past, those aisle-like or chimney-like business is now changed. Now, we do not need to replicate so many instruction lines. You only need to can do very little work, and then you can finish automated employment and go along with automated operation and maintenance. Therefore, for our solution, our bandwidth is ultra-wide, and our connection is very intelligent, and our operation and maintenance is highly intelligent and automated as well. And we have been ranking the first in market share in China for several years in a row. And also, you can say Cisco's market share keeps dropping, and our market share keeps going up as well. And we have been given awards this year for have been given several heavyweight awards this year. And you can say we have been given Frost & Sullivan Global Technology Driven Leadership Award. And also, we have global partners as well. We are going to join hands with our global partners so as to enable a kind of a digital transformation of our global client. Thank you. We thank Mr. Ma for his wonderful speech. Now you can go back to your seat now. Thank you once again. Just now, Mr. Ma has described to us a high-quality campus career network. How can it bring us a brilliant future? Today we also have with us GITA Semiconductor Senior Manager, Mr. Gao, to come to this conference. And he is also a practitioner of Cloud Campus of Huawei, and he is going to share their experience in using our product and solution. Now let's put our hands together for our next speaker. Good afternoon, everyone. I'm Zhao Jinshou. I'm from GITA CTO Semiconductor, and I am responsible for the operation of 3 semiconductor plants. And what I'm going to say has to do with the use of Cloud Compact for building digitalized plant or facility. Firstly, a few words about our company. Actually, it is a full subsidiary company of Huada Semiconductor. Actually, we are conducting our raw material, as you know, are the wafers. And they are what are our products? These are those with processed printed circuit wafers. So you know we are doing the fab. We are the fab. And to use an example from our life, to charge our mobile phone nowadays, charging of the mobile phone becomes faster and faster. And also, the new energy vehicle, the charging goes faster as well. The faster the charging, the higher the risk of explosion. Therefore, you need a very good power switch or power conversion efficiency. Otherwise, when the power goes up, there is a higher risk of explosion. Now, for our fab, I will skip the introduction part about our company and factories. Before I come down to business, I want to say a few words about the semiconductor industry. The semiconductor industry has 3 following models. The first one is design house, which is called fabless. They focus on design. And the HiSys of Huawei is fabless.
They may design circuits, and then they need a fab factory to make the chip. And this is another business model, which is called fab. And in China, one of the top makers is ZTE. And IDM is integrated design and manufacturing. So one example is Intel. They do both designing and production. So these are the 3 typical modes in semiconductor industry. So first, we buy a silicon chip. After it is processed, a processed wafer is sold, and then it's cut into pieces. Maybe you have seen CPU. CPU are encapsulated chips, and then they are sold to factories who will assemble the chips into products, and then the products are sold. So this is a very long process. from a silicon chip to a finished goods? Well, for us, it is very difficult to do fabrication. First, silicon chip have the same elements of sand, but our material is having a 13.9 concentration. So within 100 billion elements, only one of them is not silicon. So our material is highly concentrated. And now there are 5 main providers for our materials. UVD, PVD, they are working on films, and KOA from America, who are working on measurement devices and LAMP. And Tokyo Electronics. These are the major vendors for us if you want to make an advanced chipset. If we only want to purchase some used materials, it is difficult to make advanced chips to satisfy Huawei's needs. Since 1940s or 1950s, America already started their semiconductor technologies, but we didn't have anything at that time. So there's a big gap between us and American industries. And now in Japan and Korea, they really need to build photoresisted. And we need electricity level sulfuric acid. That is a concentration of millions. There shouldn't be anything involved, otherwise the yield rate may be lower. So we need highly treated, pure material. All the materials of chipsets are highly concentrated, very pure. And also we need analog vendors, because we need to do photoresisted technology. And there will be some changes on the very edges of the material when we are doing photoresisting. So we need to correct the changes. Now in our industry, we have Synopsys, Tandem, and Mentons, the 3 vendors who are now working on the correction of photoresisting changes. So you have to work with them. There are now many challenges in the industry. This is only a brief introduction to our industry for your understanding. And in our manufacturing, the process is quite long and complex. I don't want to talk too many details, but later on, I have some examples to show you our challenges lying ahead. As a manufacturer of semiconductor, we are now also going into Industrial 4.0, and we have already invested a lot in our production line. 8-inch production line may take billions of dollars. And even a factory that is producing 12-inch chipset, that may also take a lot of money, billions of investment. Now in Industry 4.0, we have high requirement on network to make our semiconductor factory digital. In a production line 20 years ago, there were a lot of manual work and operations. You need to operate jobs. You need to operate work orders. And then several years later, on a 8-inch production line, it is already semi-automated. You feed in the material, and then the output is generated automatically. But the moving of material is not automated. And later, several years later, we have already made the whole process automated. But it may take about 100 million to build an 8-inch chipset production line. So what are our requirements on network? First, it should be highly reliable because our production is 7/24 hours without any stop or interference. If there's a stop, then big troubles may come. So reliability is the first priority. The redundancy should be N+1 or 2 Ns. Second is speed. After full production is initiated, our output every day is more than 10 billion. Every hour, the output is around several million. And if there's a network failure, the whole factory is affected. So reliability is very important, is pivotal. And for our semi-job, it may take 30 minutes on a photoresist machine. And when we start a job, because there are many communications in between, we require to finish the job within 30 seconds. Many telecommunications are needed in the process, but if there's a congestion, then a big loss may be incurred. For a 30-minute job, for IT, it's 30 seconds. Then for the whole company, a lot of time may be wasted. And for IT, that may cause a loss of millions of our cost. If we can improve the whole process by 1 second, then a cost of 5 million can be saved every year for the whole company. Therefore, the network should be highly responsive. And next is security. This is a pretty complex issue. I think every one of you must have heard of the malware several years ago. That was a case for Taiwan Semiconductor Manufacturing Company, the TSMC. A stop of 2 hours resulted in a loss of $200 million. Therefore, we need a network that is highly available, no matter in terms of wireless or wired network. For a digital semiconductor factory, we require high reliability and availability. And now we already have 5,000 devices, 5,000 accessing points on the network and about 4 million devices on the network. But there's only one administrator of all these accessing points and the devices. So we also have many pain points. Later on, I will tell you more about our pain points. But first, I will talk about how we solve these pain points. First, we deploy the Wi-Fi 6. Every week, we have routine meetings. We are able to see the reason behind why there's a congestion. This is a pretty big pain point that has been solved. So, as I've mentioned, for a digital semiconductor factory, reliability is the first thing. We cannot afford even one stop on the production line. If you want me to feel assured, then please give me high reliability. Whenever there is a trouble, I need it to be shooted as soon as possible. And secondly, we need lower latency. There shouldn't be any congestion on the network. We should have guaranteed experience. And thirdly, we are able to use better awareness function to sense possible risks and threats such as a malware. So if in the future you are also going to run your own digital factory, then maybe you will have my similar requirements. As I've mentioned, there's a pain point. For example, a lot of people are having meetings together, then they cannot access internet freely and smoothly. This is a very big headache. Or maybe there is a point and there are jitters. The AP point can be accessed from now and then, and we don't understand why. We cannot find any clue to explain this. But now, when we have intelligent operation and maintenance software, we are able to locate the malfunction or the failure very rapidly. And in Huawei products, we have indeed resolved all the pain points we've met with. So, in my session, I've introduced you what we need for building a digital semiconductor factory. We need high availability, high reliability, high intelligence, and high security. These are some requirements for us when we are designing a digital factory. And also, I've shown you how we use Huawei products and solutions to solve these challenges. I've shared with you these practices. I'm very happy to see you all today. Thank you.
Thank you, Mr. Zhao, for your wonderful speech. Please be kindly seated. Thank you again. Just now, through introduction of Mr. Zhao, we have a better idea of a digital factory. The three guest speakers of our breakout session have wonderful points to share with us. And besides speeches given by our speakers, we have also lucky draw for our friends here. You can scan the QR code with your mobile phone and follow our account and fill out the questionnaire. After that is done, we will begin our lottery on our mobile phone. We have prepared wonderful gifts for you, which is a Huawei watch. If you are lucky enough to get that gift, you can keep on your mobile phone a screenshot of that and then get the gift at our reception. Today, we have had speeches about the development and the application of our campus network solution. With that, we will wrap up this session of discussion. I wish all of you a happy life. Thank you.